Hey class, this is Mr. Reed again. We're going to be wrapping up Unit 4 in the blueprint book, going over scale sizes and thread specifications on bolts. So, as we were talking about before, we've been over a lot in Unit 4. We've talked about tolerance, linear and angular dimensions, a lot of different things. So, what I'd like to talk to you today to go ahead and wrap this up is scale sizes. Now, the reason you draw something to scale, you can imagine the people that were designing the Eiffel Tower, you know, they're not going to have a piece of paper big enough to draw that on a 1-to-1 scale. They had to scale it down, you know, 1 to 1,000 or something like that. And that's what you do when you scale something out. Now, when you see scale sizes, you're going to have a fraction, and then you're going to have usually to 1 inch. So each ½ inch that you have on paper is going to equal an inch in real life after the part's been fabricated. So what's on the left represents the size as it is on paper, and what's on the right is your real life measurement. So if it's a 1/2 scale, the size after you fabricate it is going to be illustrated on your print by exactly half of that size. So we're talking about 1/2 scale. So on paper here, I kind of drew you something up, and if you measure it out while it's on paper, and it has 4-inch length, well, in a 1/2 scale, this is half of the size that it would actually be. So after you fabricate the part, it ends up being 8 inches. Another one here for practice is a 1/4 inch scale. So if it's 4 inches on paper, notice that both of these are 4 inches, but 1/4 inch scale means that there's 4 quarters in an inch. So you take this and multiply it by 4. So after you fabricate the part, it's going to be 16 inches long. So a 1/2 scale, it takes 2 of these to make 1, so it takes 2 of these to make your part, the actual length. It takes 4 quarters to make a whole, so you know to multiply this times 4, so you end up with 16 inches. Now, just keep in mind, what's on the left is on paper, and what's on the right is in real life after you fabricate the part. Now, scale sizes can go both ways. You can have a 1/2 inch scale, but you can also have here a 3-to-1 or a 2-to-1. And that's when you have a really small part and it needs to be blown up on paper so that you can see all the details necessary to fabricate the part. So if you had a 2-to-1 scale and it was 4 inches, after you fabricate the part in real life, you're going to divide it by 2. And this would actually be a 2-inch long part. So that's scale sizes, guys. You know, that can be confusing, but I hope I simplified it to the point that everybody understands. If you have any questions, as always, I have a hard open door policy or ask your current instructor. And moving on, the last thing I want to cover is thread specifications. When I was younger and I would lose a bolt, I just thought, you know, there was no way to get that bolt again. You know, it came in the box, whatever I was building. If the bolt was lost, there's no way. But a friend of mine showed me that at Ace Hardware, they have all kind of those fasteners and bolts, and the threads on these bolts are common. So you have coarse threads and you have fine threads. And what you need to do to find the right bolt is find the right thread specification. If you were to go to Ace Hardware, you need to know how many, what the diameter of the bolt is, and that is indicated by your fraction here at the start. That's the diameter of the bolt, the distance across the bolt. Then the next number is how many threads per inch. And if you have 10 threads per inch, that's generally going to be a coarse threaded bolt. I've seen them go as high as 24 threads per inch. And anybody who's done a lot of mechanic work and everything, you know the difference between fine threads and coarse thread bolts. Alright, so you got the threads per inch. You got the diameter of the bolt, threads per inch, and this 3-letter acronym stands for Unified National Coarse. That can also be a UNF, Unified National Fine. So that's the difference. It's just letting you know the coarse thread versus fine thread bolts. The next digit, 3, is going to be your class of fit. if you've ever ran a bolt down into an engine block and you have a little bit of jiggle room and a little bit of slop where you can still move it around, that's kind of a loose fit. And that's what this indicates. 3 being a pretty loose fit, but 1 being very tight. Fine thread bolts are really bad about not having any jiggle room at all. They're easier to break because they have a tighter class of fit. And that's what that'll indicate. And then LH here at the end indicates left-handed threads. And what do you use all the time in the welding lab with left-handed threads, reverse threads? That's going to be your acetylene rig on your torch. All that is left-handed threads. Now, if it's just a regular standard right-handed threads, it's not going to be indicated with an RH. The only time you'll see any kind of indication on the end is if it's left-handed threads, because that's not standard. It's kind of a special set of threads. So you've got diameter of the bolt, threads per inch, an indication whether it's coarse or fine. You've got class of fit, and you've got which way the threads run on that bolt. So we've covered scale sizes, and this should wrap up Unit 4. It was a lot of content. I appreciate you attending class, and if you have any questions, again, Mr. Reed or your current instructor. Have your pet spayed or neutered.